How's it going? Real simple. My name is Ryan. I lead the software engineering team for the fixed wireless internet product at T-Mobile. My colleague Forrest here manages our geospatial data science team. Let's get into it. So we're going to talk about, in general, like what our product is. A lot of people don't know we actually sell an internet product, and it's not a hotspot. I think people buy hotspots from their telco, whatever, but that's not what we are. And then, honestly, being kind of a unique business, fixed wireless is sort of, in the US at least, like it's not something people are used to for providing their internet. So, and it does provide, as composed of like fixed wired products, for instance, has unique challenges that we have to reconcile with. So what is it? So, like I said, we sell a fixed wireless internet product. For those of you who don't know what we mean by fixed wireless, just break that apart. I think we all have a phone of some kind. We have wireless, it has a radio in it, there's a tower somewhere. It is beaming data, we receive it, and go on. And it's generally a mobile product, right? So when we talk about fixed, T-Mobile's network, most telco networks are built for, cars driving down the highway at 6 miles per hour and making sure your call doesn't drop. And that's a core function of the network, but if you have a fixed product, that's a very different problem. And a little bit of a spoiler alert, do our products stay fixed? They do not. So we have to sort of reconcile with that because we don't have an unlimited amount of bandwidth in our network, right? So if we're trying to maintain a good level of quality for all of our customers, we have to pay really, really close attention to where our customers are and how they're using our product. So there's a lot of problems. Like, we don't really have time to go through all the problems and challenges we do. They're all very interesting. We can sit here and talk all day about them. But there's basically three that we're faced with on a daily basis. And one being that we're not just a growth product, we're a hyper-growth product. We've been in business for roughly 3.5 years now. We started in the hundreds. We're now in the millions of customers. Relatively speaking, in terms of businesses, that would be considered hyper-growth, right? So in a very short amount of time, we've had to grow very fast. Just for a comparison, just so you have something to relate to, Q2, we were not only the fastest growing ISP in the United States, we were almost more net activations than every broadband provider in the United States combined. So when you think about that many devices being shipped out, we have numerous problems from anything from supply chain logistics to COVID to how do we support all these customers? Do we know where they are? Are we activating and identifying the right customers? And that's really where we get into location. Because our business, I can't say this enough, location and geospatial is everything. A customer, and we have really good customers with bad signals in rural areas, and we have really bad customers with good signals in urban areas. And there's just so many different permutations of that we have to kind of deal with. And obviously performance. A lot of times we might have a very rich backhaul to the tower itself, but once the equipment starts beaming out data, it's not quite, we definitely have finite capacity, and we have to be really careful about selling in fallow capacity areas where we can meet our commitments as a US broadband provider. And if you don't know what that means, it's, we have to do 25 megs down, 3 megs up, right? The other item, I think, especially with fixed wireless, because I think everyone is kind of used to, you have this, when you go through your cable provider, or your DSL, fiber, whatever, there's coax, copper, fiber coming to your house. You plug it into a ugly little modem, and you hide it somewhere. And you never look at it again until you get a spinny thing when you're trying to watch like Game of Thrones or something, right? So for us, it's quite different, right? So like, why did fixed wireless sort of become this thing out of nowhere? And for starters, it's just like there's just not a lot of competition out there, right? And not only that, but I think from a traditional cable broadband provider, you've already hit all the economically dense areas, but there's still like a massive swath of our country is not covered by, they don't have a reliable internet, they don't have choices. So with fixed wireless, where we have very simple maintenance, we don't have to pay tens of thousands of dollars per household to get a line to your house to get internet, where we just have a tower set up and we're serving thousands of customers. As long as we have fallow capacity, we can reach you very cheaply, right? Also in the recent, if you're not aware, like the FCC has all these spectrum licenses. They're different frequencies from low, where you get very high propagation, low speeds, to very high frequency with a very kind of short horizon or buffer around where that service is. So there's available. We purchase those at auction, pay a lot of money for them. Just a wider variety of those nowadays. The radios themselves on the phones, the spectral efficiency is much better. There's band steering, MIMO, you can look these up online after, we don't need to go into these, and several others that actually make it more efficient for the phone, so we can spend more time handling all the data hitting you and less time just trying to handle the signal. And then finally, this is one like people don't really think about a lot, but it's content providers. Like you're getting internet because you need to consume content or you need to connect to something or something. So when you think of Netflix and YouTube and whatever, but traditionally most broadband providers want you to think you need a 1 gig or 100 meg connection to watch YouTube. And maybe 10 years ago that was kind of true. But when you're kind of reviewing, if you're catching these Cardo sessions on YouTube after the conference, I challenge you to like open up your activity monitor on a Mac or whatever you have to look at network traffic and take a look at it. And you'll see it rarely goes above, if ever, goes above 25 megs. So you don't really need as much data anymore to consume all the content you're used to doing. So you don't really need all this excess speed. That's the big myth in our industry, right? And never mind that even some of the larger providers like Netflix, they even build specialized hardware that's co-hosted on the towers that can allow things like edge caching and things like that to make it just much easier and require less data to consume content. So. And yeah, like I said, location's everything. This is a data science conference. Let's start getting into location stuff and let Forrest take over.
Yeah, thanks. All right, why do we need a geospatial team? My boss is in the audience, so this is also me getting some job security on this one. So we're talking about, Ryan mentioned this term of fixed wireless. And what we mean by that is literally that you have someone in a fixed location served by a wireless network, right? So a traditional ISP, they're thinking about, if we're thinking about vector data, they're thinking lines and points. How do you layer lines to get to your points? We're talking about intersecting points with polygons. So by nature, you have a spatial problem to tackle. To do so, you need a lot of data. It's not only the complexities of the shape of the polygon coming off the sector, but it's also things like seasonality of foliage. Like that's something that can totally mess up your cell signal at your house. It can also be things like if the structure that you live in is a brownstone or made of brick versus traditionally wood-studded framed house. Things like that can contribute to the service quality of your cell phone in your house and just generally the 5G connection that you get. And I'll talk a little bit more about those decisions, but the factor that Cardo plays here, and we'll get into our whole tech stack in depth. That's whatever remaining time will keep you glued to your chairs for a while on that one. We leverage Cardo by being able to visualize data as seen in the map here. So Ryan touched on this. The traditional ISP is thinking about the ROI for connecting a house in terms of the lifetime value of laying a cable to that customer. I live in Central Oregon. It can be pretty rural. If you live out in the middle of nowhere, and I'm from Vermont, so I'm very familiar with rural places. If you live in the middle of nowhere and you hit up CenturyLink or whoever, you're like, hey, we want fiber internet to our house. They're going to be like, okay, cool, it's going to cost us $20,000. Can your community subsidize it? Can you pitch in? And you're going to be like, no, man, like I'm just trying to watch Netflix. I'm not doing that. The perk of a fixed wireless option is that there's no cable to lay, right? You just simply get this gateway, combination router, what's it called, the gateway again?
It's called a gateway. Yeah.
Router modem combination gateway. And you're able to just plug it into the wall and connect to the same 5G network that your phone uses. So it's greatly simplified, and when you think about the ROI of that determination, we're talking about 5G spectrum that already exists. So it's not being built in order to provide an ROI to that customer. We're simply saying, if there's sufficient coverage, if there's capacity on the serving sector, the pizza slices in the image here, you are able to sign up for this product, plug your gateway in, and you're good to go. Instantly have Wi-Fi in your house. And to do that, to make those determinations, I touched on, the foliage example. Of course, topography is a factor there. There's also considerations of, I heard in the last presentation, talk of density. We use drive time from urban center density class designations. We partner with our network teams to do so, and then we're able to visualize it as seen here. And this type of visual is enabled, again, by Cardo and is leveraged by people on the front line in our company to make determinations about individual addresses. And with that, I'll pass to Ryan to talk about exactly how that works.
Yeah, so obviously behind all of this, there's a tech stack underneath it, right? There's a team. And I think what consistently surprises people is based on our growth, how small a team we really have kind of building all this. So there's a bunch of factors to kind of play whenever you have a small and you're constrained by people. And I think I always like constraints. Constraints give you, they pare down your solutions. They allow you to actually get there faster, in my opinion. And fast is, it's kind of an understatement. I think We often kind of measure like how well we're doing by, can we answer the questions that we're faced with faster than new questions come in? And obviously, if we're a little bit higher on that, then we're doing pretty good. If we're lower, we know we have problems. We need to be more efficient. We need to be able to answer these questions faster. And usually these questions need to be answered yesterday, right? Especially with our growth. So as we get into like tech stack, it's like small team, right? How do we solve this quality of life issue, but also answer all these questions with like a really small team? And like I like to kind of semi-joke for those who are developers, you probably heard of test-driven development. We like to practice vacation-driven development. What that basically means is like, we have a small team. We can't be around 24/7. We need our systems to be resilient and stay up, right? Because the last thing I want to do, like when I'm playing with my toddler at night, I don't want to like get off and have to like fix an issue, right? And I don't know what people without kids do anymore. I don't know what you do. Eat saltines.
Dogs, yeah.
Dogs eat saltines, stuff like that. And, but, he doesn't, we can't bring them up either, right? Because we got to protect that quality of life. We got to be efficient with what we're doing. So when we get into our tech stack, pretty simple 3-tier architecture. This is overly simplified, but also like with a small team, you have to also have a simple architecture. You can't be thinking too much about using every different language and every different tool under the hood. So we have to have some standardized things. We have to have common data models, and we have to really lean on our enterprise partners to handle privacy and et cetera, et cetera. A lot of things that we desperately need to make sure we're protecting data, keeping data clean, but also not things we directly have time to work on. So if I'm starting on the bottom up, one of the things we heavily leverage, especially at the database layer, is managed services. So if you're not familiar with that, without managed services, we probably need to hire another 2 or 3 DBAs, which we don't have staffing for, right? So managed DBs like AWS Aurora, MongoDB Atlas, Elasticache, things like that, where the whole patching part of the administration of the database and scaling of the database, when you have auto-scaling, like that's just things we don't have to worry about, right? We're also cloud native out of the box. Not only cloud native, but we're active, highly available. What that means is like we have multiple active instances of all of our services running in different regions of the United States at all times. So if, what happens to the best of cloud providers, a region goes down, we need to have a backup so that whenever people try and do eligibility checks to their service, that it's always available for them. And we're actually very successful at that. Getting into the API layer, this is honestly this is the biggest part of what we do. This is, we have hundreds of APIs that do everything from this geocoding, very, very specific answering geospatial problems, checking eligibility. They feed into our point of sale systems, our marketing systems, our care systems. They go everywhere, right? This kind of ties us in and connects to. And we also have a very platform-centric strategy with this as well. Everything's deployed in Kubernetes. If you're not familiar with Kubernetes, just a fantastic it's pretty much driven for vacation-driven development, right? Because so we can deploy our services on multiple instances, what they call pods. We have the ability to do rolling resource during the day, so we don't need to do nighttime deployments. We can do it right in the middle of the day, roll everything over, no issues for our customers, it's completely invisible. And then if there's ever an error, there's ever an exception, there's something that takes a pod down, it's isolated to a single pod. The pod goes down, it restarts, our load balancer takes it out of the pool, completely invisible to the user, spins it back up, we're back on, right? So in front of that, we also need security. We need to protect our data. Any data scientists know that most of our problem is just dealing with dirty data, right? So we pay a lot of attention because with our growth, our data can get really bad really quickly. So we have Apogee in front of that provides authentication, throttling of malicious traffic. We use Salesforce behind the scenes, not so involved in our geo side of things, but we use Sales Cloud, MuleSoft, Marketing Cloud to kind of feed into our hub, into sales and marketing systems throughout the enterprise. And a lot of people miss the telemetry piece, but it's kind of hard. You can scale your APIs and your database all you want to, but the minute something goes wrong and your telemetry went down, you can't really solve your problems, right? So Prometheus, Splunk, tools like that. We also scale linearly along with our services to make sure that we can always know how things are performing, and we know we can quickly fix things when things go down. And then finally, our front-end layer. You saw a screenshot on the previous screen. So that's a combination of Carto and our in-house application suite called ICA. We use that. We solve some very specific problems with that, but effectively it's the brain of our business. And we can solve things like if someone's calling in and they have slow service, we can pull up their IMEI. That's the unique identifier of the physical device. We can see where it's been bouncing around, if they're actually where they were qualified at. We can look at the signal power, all kinds of metrics, right, that determine or at least help us get closer to what a solution is for that customer. And of course, we have the Tableau, Power BI, things like that in the world that for our data scientists and data analysts to really get quick answers quickly, just feed directly in our APIs databases and get things done. And so I think we're going to talk a little bit more about actually the specific data science pieces of this.
Yeah, I'll be quick. We just hit time, so very quickly. We talked about spatial indexing, or Javier did this morning. I'm a big fan. I wouldn't say the same about marketing and sales organizations in our company when I send them Hexbin data, but the power of spatial indexing for the data that we're able to aggregate and then share out is pretty huge. We're talking about 185 million addresses in the country, unique addresses. And when we look at the fabric broken into hex bins, typically within GeoHex, working on going to H3, that's usually at 168 meter bins, which I believe there are 13 million of covering the country. In doing so, we're able to make much faster determinations over what the actual serving sector is for a given area. So in the visual here, all of these brown dots is Las Vegas. All the brown dots are actual sectors, and then the green, red, yellow, orange indicates places where we have capacity for our product. And so you can see we end up, if you ever go to our website and you're like, my neighbor is qualified, I'm not, why was this? We have this very nuanced model that ends up looking something like, I don't know, I think of it as a petri dish, like bacteria. It's not the official classification, where it's spreading out. And we also know that when we're making these determinations, the more data, the better. So part of that spatial indexing approach is that we're able to collect it to those hex bins. And as I mentioned before, I mean, one of the things that we do as a private sector company internally is that we need to make sure we're enabling our partners. Again, they're not super into the whole hex bin thing. So a big focus of the work that our team does is enabling those teams by converting to things like zip code. So here's my Drake marketing meme. And yeah, I think that's it. So we'll open it up to questions if we have time. Thank you.